Hello and welcome to another video. Today we're going to be working on minimum deletions to make character frequencies unique. And so in this problem you have a string s that's called good if there are no two different characters in s that have the same frequency. Given a string s, return the minimum number of characters you need to delete to make s good. The frequency of a character in a string is the number of times it appears in the string. For example, AAB, A is the frequency of 2, B is the frequency of 1. So in AAB it's already good, and AAA, BBB, CC, so A has a count of 3, B has a count of 3, and C has a count of 2. So here you would need to either make A or B decrease one of them to make it unique, and you need to decrease one of them to 1, which would be you delete 2 characters, so that's the answer there. And then for this one, we have A equals 3, and then we have B equals 2, C equals 2, and E equals 1. And so here you can delete both C's, resulting in the good string E A B A A B. Note that we only care about characters that are still in the string at the end. So if you delete one of these characters, either the C or the B, because you can't make them 1, then that would be unique. And so you are allowed to delete multiple characters, so that is something you are allowed to do. Like, for example, let's say you had, just to give you an example here, so let's say we had a string like this, right? A, B, C. Then A would have a count of 1, B would have a count of 1, and C would have a count of 1. So in order to make them unique, we need to delete 2 of the characters. So 2 of their counts would go to 0, but that's fine. So that is one little caveat on the problem that they show you in this third example. Okay. And so the way to do this problem, especially in Python, is very convenient. And the thing you need to know for this problem that is going to make a lot of this easier is if you have a dictionary of letter counts, right? So if you have a dictionary of counts of A, B, and C, and so on, that is technically O of 1 time and O of 1 space to get. So obviously to go through the actual word is not O of 1, but if you have a dictionary of letter counts, that is O of 1 space, because no matter how big the word is, you're only going to have 26 keys, right, for every single letter. Obviously, if the key can be every single, like character possible, then that doesn't count. But assuming, our keys are limited to lowercase letters, which they are in this case, then it's fine. And I believe they are limited to lowercase or even lowercase and uppercase. It's still a constant value. So a string can be billions and billions of characters, but you're still only going to have 26 keys. So making a counter, where you just have, for every letter you make a count, is free for us. And so what we're actually going to do is we are going to make a counter. And so let's actually go through this example AAA, BBB, CC. Because AAA, B is fine, but for AAA, BBB, CC, what we're actually going to do is make a counter. So for A, in Python, a counter is just the key is the letter, and then the count is the value is the count of it. So we'll have like A3, B3, C3 or C2 is our counter, and we can just make this like, we can call it whatever we want, right? Count or something. So for count, we'll have A will have count 3, B will have count 3, and C will have count 2. And that's totally fine. Now, we don't actually care what these characters are. We only need to know about the values, because we just need to make sure that the values are unique, that the counts are unique. We don't really care what letters they are. Like, if this was A and B, or if this was Z and B, it would still be the same solution. So we really need the values of the counter. So we are going to make a counter, but then we're going to get the values. So our values is we have some letter that we have 3 of, some letter that we have 3 of, and some letter that we have 2 of. Now, remember that I said this is basically free, and so you know what else is basically free? Sorting this. So sorting 26 keys is O of 1 time, because it can only be 26 and that's it. So we're actually going to sort them as well. Now, obviously, in terms of like LeetCode efficiency or something, it's not, it's not free, but in terms of big O, it is free. So making a counter, the space is O of 1, sorting a counter, the time is O of 1, and so on, right? Because it's only 26 characters, that's the max. You can have as many letters as you want, still this will only be 26 keys. Okay, so now we sort them. Now basically what we need to do, we need to get to the end goal of all of these need to be unique, right? You can't have 2 counts that aren't unique, but there is one caveat here. They can be unique, but you can have multiple zeros, right? Because deleting, all of one character makes it not count. So all of them need to be unique, but you can have multiple zeros. So the problem basically comes down to, how do I make all these unique or have multiple zeros quickly? And so what we are actually going to do is pretty straightforward. We're going to have a set, and we are simply going to check. We're going to go one character by character, and we're just going to check, is that character in our set? If not, let's add it in. And if it is, then we need to keep decrementing it to get to a character that's not. So for example, we need all these to be unique. So for 2, we're going to say, is it in our set? No, it's not. So 2 can be left as is. And then we're going to add 2 to the set, and we're going to say, is 3 in our set? No, it's not. So we're going to add 3. Now for this 3, we are going to decrement it until its value is no longer in our set or it's 0. So we're going to decrement it to 2. We're going to check, is 2 in our set? Yes, it is. So we can't have it at 2. Then we're going to decrement it to 1. Is 1 in our set? No, it's not. And now this is our solution, and we just simply keep track of the number of decrements. So in this case, it would be 2. Now let's do the same thing for this other word, CEABAACB. Okay, so once we make the counter, remember we just need the counter to get the values. We don't really care about the letters. So we have A is 3, B is 2, C is 2, and E is 1. There we go. We're going to get these values, and we're going to sort them. So our sorted list would look like this. Right? And obviously, this wouldn't work because 2 and 2 have the same count, so we are going to need to fix that. But let's just go through our algorithm as we did it before. So we're going to have this set. We're going to go through our values and just check, is it in there? So we're going to see, is the 1 in the set? No, it's not. Okay. Is the 2 in the set? No, it's not. Now, is this 2 in the set? Yes, it is. So for this 2, it is in the set, so we're going to need to decrement once. Now we have 1. Is 1 in the set? Yes, it is. We can decrement to 0. And 0 is always going to be acceptable, and we never need to add it to the set. So decrementing to 0, like as soon as it's 0, we can be done with that number and move on. And so far we made 2 decrements, so our count is 2 that we made. Now for this one, is 3 in the set? No, it's not. So we can just add it in. And so our total decrement is 2. And as you can see, it is there. So that's pretty much it. You literally just get the counts, which in Python there's a counter that I'll show you. That is literally one line. And then you get the values, you sort them, and you just go value by value, and you make sure, is this value okay, or do I need to keep decrementing? Remember, all you can do is delete characters. So we're just going to keep deleting characters until it's either 0 or it's something that we haven't used before to make sure uniqueness. Now, the nice thing, like I said, this set is O of 1 space because the most it can ever have is 26 numbers, right? This sort is O of 1 time because 26 numbers. And when we loop through the character and we decrement, for every character, the most we can ever decrement it is 26 times. So for every iteration of the loop, the most that can ever happen is 26 times, which is also O of 1. So the nice thing is, by using all these letter things, using a letter is much better than like looping through the string because you can only have 26 letters. So you can treat that as constant time and space for most of these things. So let's code it up, and we'll go over the actual time and space for this solution. So we need to get the values in this counter. So we're going to say values equals sorted. What sorted does is it sorts something. We are going to want to get the counter of S, which is just the key value pairs, right? But we don't want the key value pairs, we just want the values. So we're saying, let's get the counter of S. So for example, if we had A, B, B, C, 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 it would be like A1, B2, and so on. That's what the counter would give you if you give you a dictionary of these, B2, C3. And now the values just gives you an array of all the values. So values would give you 1, 2, 3. We want to sort them as well. Now we're going to have taken values, which are going to be a set, and that's going to represent all the values we've currently used, and every value we need to make sure we haven't used it before. And we're going to have a result. So then we can have for value in values. We just need to record it somewhere, right? Like original value or something maybe equals value, and then we can say, we can say while. Just say value in taken values, we need to keep decreasing it, right? So we need to say value minus equals 1. Then we need to check what the value is. So if the value is non-zero, then we need to add it to our set. So if value is non-zero, then we can add it to our taken values. Otherwise, we don't really need to add it because we don't need to add 0. We just stop there, right? And then we need to add however many subtractions we made, and the subtractions we made are going to be original value minus value, right? So we did some number of subtractions. So let's say we had 3, we made it go down to 0. That's 3 subtractions, and so on. So the number of subtractions is the original value minus the value you finally had at the end. And then finally, we need to return the result. So let's see. Original, probably misspelled as always. Okay. And let's take a look. And you can see it's pretty efficient. And that's a nice thing about, even though you have all these loops, let's actually go over the time and space here, just to explain it one more time. So if you think about it, this counter, so making the counter is actually going to be not O of 1, right? Because we do have to loop through the entire string. So we do have to loop through the entire string. Let's call that O of n. But once we get the counter, remember it's 26 keys. So sorting 26 is O of 1. Now we get the set. Then for every single value in values, remember we only have 26 values, constant number. And then here we also have maximum 26. So it's a for loop. It's like a nested for loop, but the upper bounds of each for loop are only 26. So because it's constant, this whole thing you can consider as O of 1. Because like I said, no matter how big your string is, you can only have 26 values, and you can only have 26 items in your set, so the most you'll ever decrement is 26 times. So the biggest thing this can run is 26 times 26, which is like, 500, which doesn't really matter when your number is like 10 to the 9th or something, right? It's basically doesn't matter. So the time is actually going to be O of n, which is just traversing through the string. And for the space, that's the other nice thing I would argue here. So this counter is O of 1 space because, like I said, only 26 letters. These values, array of only 26 maximum. Taken values, set of only 26 numbers maximum. So this set is O of 1 space. This counter is O of 1 space. This values is O of 1 space. Now, if your interviewer did ask you, like, well, if it is an O of 1, what can you represent it as? Then you would say, like, okay, yeah. So if you don't want me to count it as O of 1, then I would basically have to figure out, like, how many unique characters are there in here, and then the counter would basically be of, like, let's say unique character is called like U or something, then the length of the counter would be U, and then the length of values would be U, and then sorting it would be like U log U or whatever, right? If you wanted to talk about that. And same thing here, it would be U times U for this part, for the time, and so on. But I'm going to say, for my case, the time is O of n, and the space is O of 1, because like I said, you can only have 26 character max, so that's constant space and time. And yeah, that's going to be it for this problem. Hopefully you enjoyed it. Like you saw, we have a pretty good solution here. And yeah, if you did like the video, then please like it, and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.